Terminal Velocity Aerospace is directly addressing two markets in the space industry. The first of those is for reentry data, and that has application to help improve safety for launch vehicle stages and spacecraft as they reenter. The second market is for small payload return, which has application to increase utilization of outer space. We're serving these markets through our suite of small reentry devices, or REDs. The first of those is called RED Data, and it is currently available. It essentially is like a black box recorder for a spacecraft that survives during a reentry event. The team consists of myself, Dominic DePasquale, Dr. Robert Braun, and Dr. John Olds. Between the three of us, we have over 60 years of experience in the aerospace industry, and Dr. Robert Braun is one of the world's leading experts in planetary reentry. The market need for reentry data arises out of the fact that we really do not understand what is happening during a reentry and breakup event. And because of that, it creates risk and it forces us to be conservative. So there are several opportunities that are available, and we've spoken with several potential customers in the both commercial as well as government sector who have indicated that they have a high interest in this reentry data to either improve their reentry risk predictions, to design their spacecraft to intentionally break up so that it doesn't cause hazard to people and property on the ground, or to design their vehicle so that it does survive, so that it is reusable. There's also the benefit of extending the on-orbit life of satellites. Satellites currently carry some propellant that they must use in order to intentionally deorbit themselves at the end of their lifetime. But if we better understood what was happening during reentry, we'd be able to allow those satellites to stay on orbit longer. And the revenues that these satellites typically generate are on the order of several $100,000 to several $1 million per month. So this is a significant benefit. The solution that we are offering is called RED Data. What RED Data is essentially a basketball-sized device. It rides along with the customer's launch vehicle stage or spacecraft, travels to space, and when that stage or spacecraft has completed its mission and deorbits, the RED Data device wakes up, and it begins collecting data during the reentry and breakup event. It collects pressure and temperature and accelerations and so on. It survives reentry, and then it broadcasts or transmits the data that it's collected back to us at Terminal Velocity Aerospace, which we then deliver to the customer. The enabling technology for this is called the Reentry and Breakup Recorder, which was developed at the Aerospace Corporation in partnership with NASA Ames. Several $1 million have gone into this. Reber was successfully flight proven on the HTV-2 vehicle, and there are currently 2 more demonstration units of the Reber that are on orbit that will return with the ATV and HTV vehicles respectively. Reber is the underlying technology for our first product, RED Data. But RED Data also serves as a springboard for us to offer other products and services. And the first of those that we are currently working on is called RED Sensor. It's in the safety and data category on the left side of your screen here. Essentially what that is wireless sensors distributed throughout the host vehicle so that we can collect a much more robust and high-quality data set. We're also working on miniaturization of RED Data and RED Sensor. I said that these things are basketball-sized devices. We can get them down to softball size so they can be much more easily integrated with our customer vehicles. In the utilization and payload category, currently available, we have a device called RED Test, and essentially what that is the RED Data core, but it allows our customer to put their own thermal protection material or small electronics, whatever sort of small space technology they want to test and qualify, which is a huge deal in the space industry. And then we are working on a device called RED Treasure, which will be a recoverable version to return small novelty items from space. We're doing this through our R&D relationships with the Georgia Tech Space Systems Design Lab and the Aerospace Corporation. In terms of revenue, a key part of our business model is low investment to first dollar. We need to sell only 2 RED Data units in order to be cash flow positive, and then our projections show that we can have revenues of about $5 million by the end of the 6th year. Total revenue potential is around $21 million per year for the products that I showed on the previous page, and there are others that we're also working on. The Amount of investment that we are seeking today is simply $150,000. And what that does is it allows us to pay for some of the non-recurring expenses associated with production of the first red data unit. It also has the benefit of unlocking or activating grant funds that can go to the Georgia Tech Space Systems Design Lab to be used on development of these other devices, miniaturization, as well as development of red treasure. We can provide, or we're forecasting a 20x return on this $150,000 within the 6-year time frame, and the most likely exit scenario for the investor would be buyout. So they would own an interest in the company, and we would buy that back. Earlier exits are possible at a lower rate of return. Thanks, and I'd be happy to take any questions.
Can you help me understand again how understanding or how having a better comprehension of the deorbit process with the vehicle is actually going to provide on-orbit life extension, particularly I would imagine at GEO where that's of real value? I'm not sure I'm understanding that connection.
Yes, this would not have an application at GEO. It would be for LEO satellites only, right? Okay. Does that answer your question? Yeah. Okay.
Yeah, I appreciate this whole concept, partly because it's simple and proven already by the Aerospace Corporation experiment, also because of these adjacent markets that are pretty obvious when you start talking about other things. One market you didn't touch on too heavily, but I think it could blossom in the next decade is early sample return from research going up on Space Station or on Dragon Lab or on Bigelow modules. And to get those back from some platform like that, you need a deorbit propulsion module of some sort to slow you down. And have you sized that or looked at that about how you would get something to pop off Space Station without riding along with some other vehicle and just pop off deorbit itself and come back down? And
yeah.
How big would that be?
Mm-hmm. It's a good question. We've done some preliminary analysis of that ourselves at terminal velocity, and currently Georgia Tech is going to the next level of analysis on that. Certainly there are two, I think, sort of enabling technologies. One is the deorbit, and one is recoverability and how you do that exactly. So yeah, we think it needs to scale up to be on the order of like a 30-kilogram size device. In terms of and that would be chemical propulsion deorbit and parachute recovery, so kind of the lowest or highest TRL technologies.
Can you talk a little bit about what users would want to use your reentry as a sort of flight qualification or testing platform versus, say, what NanoRacks is planning to do with this external rack on the space station? Sort of what business do you get? What business do they get? How do you split up the market?
Okay, great question. We want to provide the service of either returning the payload, a NanoRacks, 1U or 2U experiment. You open this thing up, you put it inside, you put it out the airlock, and we'll return and recover it. That's the station payload recovery kind of service. In terms of the red test service, again, we want to provide this platform. So you as a customer would come to us and you would say, hey, I have this new thermal protection material, and I want to put it on your test vehicle. And I have already found a lot of interest for that. I was over talking to the Japanese Space Agency, and that's actually their #1 interest. Earlier this week, I was at NASA Ames, and they are about to finalize ArcJet testing on a new conformal TPS that's a felt-based silicone ablator. And they are looking for opportunities to flight qualify it, essentially. And so it's people like that have these new technologies that we'd be able to work with, yeah.
I can see markets, particularly, as Rex said, in sample returns and also your testing. I'm a little confused about why somebody would want to send cremains to the space and have them come back, you know? But more than anything else, I don't understand the IP. If Ames and Aerospace developed this, how are you, what IP is yours?
Okay, yeah, I should have clarified that. We hold an exclusive license to the technology as well as to the patent. And the patent is for any device which returns along with a host vehicle and transmits data. So that covers red data as well as red sensor. And there's a couple others that I list there in the business plan that you may have seen that are more along the lines of a true black box recorder for a crewed vehicle or something like that. It also covers that. So we've licensed that technology, and the relationship with Aerospace Corporation calls for continued sharing. So red sensor I mentioned is currently in development. Aerospace Corporation is actually doing a lot of that work right now, and we would look to commercialize it. Did that answer your question?
I had one question. Go ahead.
Sorry, maybe to add to that, I do think at the same time we are going to be generating our own intellectual property that would come out of Georgia Tech. Georgia Tech will do some development of some of these devices to a certain stage, at which point terminal velocity would have to take over and bring it to the kind of detailed design level. So there would be our own IP that's generated.
That was the question I was going to ask about, because it looks like you're making a pretty good investment in Georgia Tech to do a lot of the development here, and yet those are going to be key team members with knowledge and expertise in here. Are they going to be coming on board with you later? Is that your thought? Or, I mean, are we talking about Georgia Tech professors who've got tenure and a very comfortable situation? And what's the risk pieces there for the team with you if you can't find those guys?
Sure. Bobby's time, our Chief Technical Officer, Bobby Braun, his time is somewhat split between his responsibilities at Georgia Tech and his responsibilities as Chief Technical Officer within our company. He has graduate students that are working on this project now, and the ideal situation would be that one or more of these graduate students essentially transitions with the technology that has been developed into our company. Mm-hmm. And with the people that we have and the timelines that we're looking at, that seems like it could be a realistic situation.
But if you're fully funded, he's not going to leave Georgia Tech.
I can't totally speak to that. I mean,
well, I'm not trying to make any news here. It's a big team risk issue. Okay, you're investing in some people, and they're going to be a core part of your organization, and other people are going to want to invest in that as well.
Yes, absolutely. But to be clear, though, Bobby is highly involved, especially on the technical side.